back there. Can everybody hear me okay? Great. So pleasure to be here. Thank you all who braved the cold or flew in from somewhere. I appreciate it, as do all of the speakers. And also want to say thank you to Sebastian, Vanessa, Puya, the whole SNS team for putting this together. Actually, we could give them a round of applause because I think it's a lot of definitions around what an incident is. You can talk about an unplanned disruption, right? Impacting customers, right? This is sort of the ITSM kind of ITIL definition, that it's all about outages, service degradation, something that a customer is going to complain about, right? But I think we actually need to expand that concept. And I think you see the high-performing organizations are expanding that idea to include business disruption, right? So work interruptions, delays, waiting, those short notice requests, right? Which are the euphemisms for nobody told you until it was almost too late. All of these things are really contributing to, in one way or the other, they slow us down, they get in our way, they cause extra technical debt. They eventually, kind of death by 1,000 cuts, do impact customers, right? So, and at the same time, all of this points down to the same people, right? So any kind of unplanned disruption, either impacting customers outwardly or our business operations, I think we have to consider as an incident and look at how the quality of how we respond to it. So this talk, I'm going to kind of walk through the life cycle of an incident, but I'm going to reference a lot of people who I think are pushing this field forward, and people that I think you can learn from as well. But first, before I kind of talk through the cycle of an incident, I want to touch upon the context, right? Where's all this coming from? What's the sauce that we're all marinating in, that's driving towards kind of how attitudes and investment is changing around incident management? I want to start with digital transformation, right? Don't groan or run for the exits. But really, this is kind of driving the root of the influence, the stress that's being put on the system, and it's really kind of coming from a board level, right? And I've seen a lot of these communications from boards to the technology organizations, and they have these new demands. One is everything's got to be integrated, right? No more of these. I want my certain things you can do on the website, other things you have to call the customer service agent. The customer service agent has 3 or 4 systems that they can, swivel chair, take data from here, look data from there. Everything's got to be integrated into one system, which creates a whole lot of complexity that we never had to deal with. Things have to be responsive, and I don't mean responsive like the website responsive. I mean respond to the business, respond to the customers, respond to pressures of the market. They want the technology organization to feel like it's not like they just push something there and maybe it'll come back, but they feel that fast responsiveness. They want things everywhere, right? They want it on the mobile, they want it on desktops, they want your Siri to and your Alexa to also they want it all the channels together, right? And they want it always got to be on. The idea of 2019, 2020, the idea of change windows, right, or maintenance outages is not acceptable, right? And so all this is being pushed down in terms of directives to the technology organization. First person to mention, Cornelia Davis, does a great job of talking about, in her books, talking about how these business transformation desires are influencing the architecture and design of what we're doing in the technology organization. So that takes us to, that pressure that we're living in takes us to the cloud native and microservices, right? Where now we've seen this explosion of this dynamic infrastructure. We got to move faster, things more integrated. So now we got this new infrastructure. The things that the complicated menu of what we have available to us is exploding. Folks like John Willis, Kelsey Hightower are great people to follow in this area to really cut through kind of what's real and what's not. Obviously, Kelsey's a little more Kubernetes focused. And to go with this, all these cloud native technologies is really this notion of microservices, right? And I don't know if you've seen these kinds of diagrams before, but they're called the Death Star diagrams, right? And these are these visualizations where these are all the microservices. This is for done by Cornell University. It's done of a anonymous but pretty popular social network, and those are all the microservices around the edges, and in the middle is a live traffic map of all the the interaction between those services. So the idea that we can keep this in our head has left us, right? The old days, we can have an idea of the architecture and the interactions, and we can kind of hold these things in our head or through small conversations, and that's quickly getting to be impossible, right? Just with this distributed ephemeral nature of things. So it's a lot more difficult to respond to and to understand what's happening. And then, harnessing these microservices and this cloud native technologies is this idea of being able to decouple the organization, right? Because Adrian Cockcroft, even going back to DockerCon in 2014, talked about how architecture enables speed, and speed is the advantage, right? And Adrian's been at Netflix, now he's at Amazon, and he truly sees it as the ability to harness these microservices, harness these cloud native technologies, is the ability to really decouple the organization so all the pieces can move a whole lot faster. So if we're trying to keep our head around what's going on, where the problems are, things just kind of exploded on us, right? And so now we need new ways to manage our people, because if we're managing our people in the same ways that we used to, we're going to encase all of these new ephemeral technologies, all these new microservices architectures. We're just going to encase them in the same kind of slow, silo-driven, kind of broken way that we used to work. So along came these ideas of DevOps and SRE, right? As Sebastian was talking about, and the best summaries I see are Gene Kim wrote the Phoenix Project, fantastic book. Just released a new book, The Unicorn Project, which looks at the Phoenix Project, but from the technology trenches. It tells the same story. And Gene talked a lot about the three ways, right? That it's all about flow, it's all about feedback loops, and it's all about rapid learning, right? And now he's got these new 5 ideals in the Unicorn Project. That's about these locality and simplicity, focus, flow, and joy, so on and so forth. So really, we're talking about now that. We need to empower the organization to flow faster and to move quicker, better, faster, cheaper, right? But unfortunately, a lot of this DevOps desire has been interpreted as it's all about go for dev, right? It's all about how do we deploy faster? How do we get things out there faster? How do we turn that crank faster? And largely, we've kind of forgotten about operations, right? We're pushing the same thing on operations, and now the problems are just happening faster, right? So I did a whole talk called Operations: The Last Mile that I've done over here in Europe and also done at the DevOps Enterprise Summit, that kind of talks about why operations is the last mile in DevOps. So I'd highly recommend that if you're interested in that topic. But to kind of respond to that go of development, to respond to that, we're just going to push things faster and faster. Some changes are starting to happen on the operations side, and you see Ben Traynor here at Google was the first person to coin the term site reliability engineering, right? And the term site reliability engineering, sort of like DevOps, is a terrible name, right? It doesn't really explain the best of what it's about. But fundamentally, if you think about it, it's really a counterbalance to that go nature of DevOps. And so what's really fascinating about it is really it's the principles of SRE that really make it so different than how traditional operations works, right? So things like SREs need service level objectives with consequences, right? The idea that instead of having just an SLA that is a penalty that we have to pay if we break a contract with a customer, SLOs are more internal facing, and the idea is as a business we agree on what the standard of performance is, something measurable, something that's kind of business impacting, but the consequences part is the interesting part. It's saying that, hey, development, product, operations, we all have to agree this SLO is paramount. And if the SLO is broken, our error budget is blown is the terminology that they would use. We all have to swarm to that. So literally, it's saying that we can stop new feature development. We can delay plans. We have to swarm to and fix this SLO because again, we're in the business of operating software to make money. That is paramount over anything. And if you think about how operations work, that idea that hey, we have a problem in production, we're going to stop work in another part of the business and go and help them, would be a fireable offense, right? And second, SREs have time to make better than today, to make tomorrow better than today. The idea that SREs, that we look at these as our human assets, and we have to think about how do we keep them out of the repetitive drudgery work that doesn't add value to the business, right? The repetitive things that don't move the business forward, don't add enduring value. How do we minimize that amount of work they have to do so they can maximize the engineering work, using their human brains to move the business forward, to do things that require the creativity. And so again, it's a mechanism to kind of push back to say, hey, wait a minute, we've caused problems here. We have to now dig ourselves out of. We have to swarm to these teams that are overloaded with this toil, and we have to help them become unburied, right? And that whole goes the idea that SREs have the ability to regulate their workload. So a lot of this is really about saying, there's this rapid pressure of to deploy, go. But now we need to rethink operations to counteract that. Or work together with that forward pressure, the back pressure. It becomes a self-regulating system, right? It's a very fascinating and I think different way to think about operations. Stephen Thorne, Tom Lemoncelli, Niall Murphy, Liz Fong-Jones, all great people to follow in this area. O'Reilly just released last year their first non-Google SRE book. I wrote a chapter in it, so obviously it's my favorite. It's my favorite book, but I think it's got a lot of good essays on kind of what this means and how operations is changing. So fundamentally now that's going to change, well, how are we responding to incidents and who's responding to incidents, right? If you think about it from take DevOps and SRE, we start to build this self-regulating system, right? That we're putting together these different ideas. These are just some of them, like products, not projects, continuous delivery, shifting left operational concerns, solving them in production, air budgets, toil limits, these cloud-native technologies. It starts to build a self-regulating system. And I think John Hall from BMC was one of the first people to really point that out, that DevOps is this deconstructive movement. We're kind of tearing down the fabric of how we used to manage things and rebuilding it from the necessary pieces. And this really comes out in different ways, right? We've got the Netflix and Amazon type of model, right? Where it's, no, we need to have you build it, you run it teams, right? Which actually I'm going to be talking about at 11:30 in the Rumford room. So if you want to come hear more about that. But these cross-functional teams are saying this is how we're going to build these self-regulating systems. We're going to put everybody who builds it and runs it together, right? But then you look at Google, they do it differently, right? They have a dev organization. They have an ops organization. They call it SRE. But they've built these shared responsibility models, things like air budgets, toil limits, to manage that relationship between the dev side of the house and the ops side of the house, and they've mixed and matched things in different ways. But fundamentally, if you talk to anyone from any three of those organizations, they all share the same language. They all share the same techniques. They just use different organizational models to accomplish it. So, who is dealing with operations is really starting to shift. And if you compare this to how the traditional ITSM world has always been, right? Instead of being these kind of self-regulating, horizontally aligned ways of organizing, things are much more vertical, right? Vertical meaning aligned by function, right? We put our server admins with our server admins, we put our DBAs with our DBAs, our network with our network, and we kind of centralize and specialize in these vertical silos. We give them process owners. We define inputs, outputs, triggers, metrics. We assign mid-level managers to manage those processes. And of course, what are they going to do? They're going to manage them the best they can. And in fact, starting in the late 80s, early 90s, this has kind of been one of the drivers of ITIL, right? That we've got these 26 processes. I think now it's 30-something practices in ITIL v4. And this is how we need to think about our world, is these different centers of excellence. But what ends up happening is we're kind of unintentionally encouraging these silos, right? We're saying, hey, this is your team is all about firewall changes, right? Well, that's going to be the best firewall rule changing team in Europe, right? And so they're just going to focus on that. And so it's just kind of what else could happen. You unintentionally encourage people to kind of focus on their specialties, and this work has to flow from left to right through all these different silos. We get a lot of ticket systems, a lot of handoffs, maybe all the problems that come from that. And then we also have this idea that, well, we're going to have some central body that's going to control our change. Some central body is going to help us, whether they look at it as pure change advisory or all the way as a pure change authority, all across that spectrum. It's the idea that there's something in the middle that can tell us what's going to go wrong and how do we avoid it. And if we've studied our Deming, the godfather of lean, one of his key points is, of his top 14 points is, that relying on internal inspection for quality doesn't bring quality, right? We've learned this from all these other manufacturing and domain and other kind of human endeavors, that you have to build mechanisms for quality into the system. You can't expect something from the outside to govern a fast-moving system and achieve that quality. So fundamentally, we've seen this shift where this traditional kind of vertically aligned way of thinking about our organization is giving way to this horizontally aligned, self-regulating systems. And fundamentally, there's a lot of disconnects there, right? So we see a lot of turmoil inside companies to say, on one hand, we want to do this more the vertically aligned, fast-moving, you build it, you run it way of working, and it's conflicting directly with everything that's been built in the last 20 years, kind of this traditional ITSM thinking. And Rob England and Charlie, the IT skeptic, and Charlie Betts from Forrester are, I think, two great thinkers in this area that are really kind of studying. I wouldn't say they agree with everything I say, but they're they are really focusing on how these organizations transforming, which really brings us to the next point is complexity and failure, right? That if we think about it, we've got this extremely complicated architectures. Now, when that combines with traffic from the outside world, we've really gone from a complicated system to a complex system, to one where we can't really fully gauge what's going to happen with all the interplay of these services and the data and the users and the traffic and the latency. And we've combined that with these high-velocity organizational designs. Really, we've created this complex world for ourselves. And there's one thing we know about complex systems is, they always fail, right? J. Paul Reed, who's spoken at this conference many times, he's kind of the one he's been hammering on is the idea that our world is complex, right? It's not deterministic. That if we come from the dev side of the house, we tend to think in deterministic ideas. Like if Nginx compiles, right, then things are good. It's going to work, right? I understand how all the parts come together. But you put Nginx in together with a complex microservices architecture, you turn it loose into the wild with all of the cloud platforms you might be running on, with the traffic you might be seeing from different users, with all the different pieces you can't control combined with the pieces you can control, things quickly become complex, right? And in a complex system, we can never perfectly predict outcomes. We can't predict what's going to happen from the sum of the parts, right? It's like the difference between an engine of a car, which is complicated, but we know, we can model out all the parts and understand how the engine's going to work compared to traffic out in the street, right? We can't take any individual car or street and understand how all that comes together to form our traffic. And Richard Cook, who will appear later in this presentation, he wrote this paper. He's actually an MD. He's a doctor, right? He's an anesthesiologist, but he's one of the foremost researchers in the world on why complex systems fail, how disasters happen in the real world. And it's a great paper to look up. It's very short. It's like 5 pages, but it goes point by point. And you read that, and you'd be like, yep, this is every reason why what we were doing, we're destined for failure, right? So we have to get used to that and say, well, how do we deal with the failure, right? And Charity Majors, this great quote that I really like, which is distributed systems have an infinite list of almost impossible failure scenarios, right? And if you talk to people who are investing a lot into resilience engineering, into increasing reliability in their organization, they'll say that the more they've invested, the better they've gotten at it. They don't get less incidents, they just get weirder incidents, right? Stranger and stranger things happen that would never happen again, right? right? That in a million years, you couldn't guess that this was going to happen. So how are you going to build a test for that to look for it in the future when it's never going to happen again? Some other weird variation of that is going to happen. She has a great story about how they had an issue at Facebook where they were doing some stuff through DNS, and if a DNS packet gets too big, it fails over to TCP, except one ISP in Eastern Europe, for some reason, disabled that in their DNS system, and it caused enough latency to cause a worldwide production outage because of a cascading series of effects, right? Something that would never happen in a million years. It's going to keep happening and happening. So we have to accept that failure is going to happen. How are we going to get better at it, right? Which kind of brings me to this for several years now, and I thought he articulated it really well, which is, if we think about it, in this world, this complex world we're dealing with, we can't actually see the work, right? All we see is our mental representation of what that work is, and maybe a few thin APIs or config files. So there's this above the line, below the line idea that, you can't see the zeros and ones. You can't see the bits fly by. You can only see your interpretation of it. And now when we're dealing with other people, they have their own interpretation of it, right? So now we're all trying to act on this system to either avert or respond to failure. But we all have a different idea in our head of what's going on because we can't actually see the work. So this is why, when it comes to responding to failure, dealing with failure, the human-to-human techniques are as important, probably more important than anything you can do at the technology level, because of that mismatch between what we're all thinking in our heads and what's actually going on in this system that we cannot see. And a whole bunch of folks, a lot of them came from Netflix. That's kind of this Netflix diaspora, but there's been some other influences as well. Are really bringing this safety, science, and resilience engineering ideas to our domain. And there's really some interesting ideas they have. They hate slogans, right? So I created some bumper stickers out of things they would hate. Like, there is no root cause, right? That it's a political distinction that humans want to make to say it was that person's fault or that was the root cause. The reality is there's a series of contributing factors that cause that root cause to be what it is. And so our choice to stop at any one place is a political distinction. It's not there is no actual root cause. Likewise, they get frustrated by the 5 whys. Some people call it training wheels, but others point out that it gives us this linear narrative that humans like, but the world's never linear, right? And this idea of safety 1, safety 2, that in the old version of safety, we study disaster, right? We study it because we want to avoid disaster. But they say, if you think about why these complex systems fail, it's a miracle our systems run at all, right? So why don't we study why they run at all, right? It's the Murphy's Law idea. They say anything bad can happen. They're like, no. It's a miracle that all the bad things that could happen don't happen, right? So why don't we study why things go right? Because people work the same way day in, day out. And the things they do every day that turn out well, one day you're going to have a different context, a different reaction, a different piece of information, not that third cup of coffee, something, and disaster is going to happen. So if you want to understand how to avoid failure, we have to understand how to actually encourage success. And I love this idea they have, which is incidents are unplanned investments, right? You spent the money, right? What are you going to get out of it, right? So we got to get good at learning from this. And really, I think the main point of all this is it's really about elevating the human, right? We had this kind of false hope, AI ops, right? That the machines were going to save us by taking over and running our systems. And the reality is, the operator is more needed than ever, right? If you think about these other high consequence domains, they've spent billions of dollars, decades and decades of human academic endeavor has gone into trying to remove the humans from aircrafts, nuclear power plants, operating rooms, and they haven't figured out how to do it, right? So the idea that we're now going to suddenly do that seems a bit far-fetched. So think about automation and machine learning and whatnot as more of an Iron Man suit to elevate the humans versus this computer that's going to run things. Run things for them. So that's really the context. I think it's important to understand this context because getting everybody on the same page about these different threads is how we sort of guide our local decisions about what we do with our incident. So now thinking about the wheel of an incident, right? I've got this observe, react, and learn, which is a lot like an OODA loop, right? I don't know if you're familiar with this concept, but one of the more famous military tacticians in history, he was an Air Force pilot, and had this and came up with this idea that in any kind of tactical or any kind of strategic or competitive application of tactics, you have this idea of you observe something, you orientate yourself to understand what it is, you make a decision about it, and then you act on it, right? And whoever can get in that loop faster than the other person has that tactical advantage and ends up winning. Very famous kind of in the military world. This is actually his first diagram of it. It's in the Marine Corps History Museum. But if you think about what we're doing, we're kind of in that same idea of an OODA loop. It's us versus the incident, right? And so I'd say it's kind of the observe, the orient aside, react, and we're kind of iterating on that top half the circle, and then eventually we have to learn from this incident. And so what's been going on? So on the observe side, monitoring. We all know monitoring. There's probably 5 vendors out there, right? It's been happening for a long time in our life. And monitoring is really about spotting the knowns, right? It's about, and there's some things that are good, like is it up or is it down, right? Or we're looking for certain patterns to happen. We're looking in the past to try to recognize what happened in the past. A very important thing, but it's only part of the picture. And lately we've seen this rise of observability, right? Which is really about interrogating the unknowns, right? How do we interrogate our systems? How do we see what's happening in our systems so we can solve those unknown problems or solve those things that are just shades of what we've seen before but not really sure what it is? Because again, our world is now an infinite list of seemingly impossible failure scenarios, right? So observability really kind of focuses on these 3 areas where the most innovation is happening. One is logging, right? So how do we get better machine readable logs? And the log is the event, right? It tells us what actually happened. There's metrics, which we've now lost all the context of the event. That's not good. But what is good about metrics is we know, are we speeding up, are we slowing down, are we going left, are we going right? It gives us some data point over time, which is very important to know what's happening. And then the third one, I think, where the most kind of investment these days is happening is around tracing, right? How do we take those different events in that Death Star diagram, right, and put them in the context of that single request so we can trace through and see what's actually happening. From that, those 3 vectors, we can look at kind of in real time what's going on inside our systems. Charity Majors, Adrian Cole, 2 people great to follow in this area, really doing a lot of good work. And a third one's very interesting is the idea of automated governance, right? So how do we no longer have the idea that, oh, can somebody approve this for me, or can some human watch something and say whether it's good or bad for the system, or they're implementing these compliance controls. So now a lot of work is going into we see multiple banks, insurance companies looking at how do we automate that governance. And why that's important is so much what we do in production is about maintaining that chain of control, maintaining that attestation that our controls are being followed. John Willis led a group at the IT Revolution Forum. They produced a paper on this. Charles Betts also does a lot of work around this. But the idea that how do we take these 3 factors and make it available to everybody, not just live in different pockets of the world, but make it part of the fabric and the observability that everybody has. We've seen a lot of rise also in kind of studying from disasters from the outside world, like taking the incident command system that's the most prevalent system in the world for managing forest fires and floods and whatnot, and bring that into our world now to where you see folks who are now translating that into open projects, sharing their their incident command procedures. We're also seeing we saw a lot of blending of dev and ops together, and now we're seeing actually ops start to fragment more, right? We're seeing platform engineering teams spring up, which are pretty much like centralized product teams building platforms for folks to use, and SRE becoming more the expert operators being distributed into the system. So much like we saw QA kind of be centralized and then sort of spread apart, we're seeing the same thing with operations, half being centralized, half being spread apart. The folks at Disney talk a lot about this. Standard Chartered Bank, same thing. New views on escalations, right? That we want to avoid them at all costs. A lot of the old ITSM thinking was, how do we escalate, right? How do we find the right person, escalate faster, better? And now we're saying, well, how do we first of all avoid escalations? How do we push control to the edges so we're no longer needing that to escalate? And if we do, how do we use new models like swarming, which came out of the customer support side, to say that we're putting the right people at the right place closest to the problem, rather than the long, thin chains of escalations bring the people, to the problem. And then it's time to take action, right? So, diagnostics, restoration, how do you take these actions and empower those people closest to the problem? And, runbooks were popular kind of back in the day, mostly manual, wikis, binders, right? And then we kind of lost the plot, right? That we didn't talk about runbooks, right? These were, it's all going to be configuration management, and we won't need this. But now, thanks to SRE, runbooks are back, right? But everyone's talking about now, how do we automate those runbooks? And runbooks being, the self-service access to the expert knowledge that you need to take action, right? And this is something that my colleagues and I at Rundeck do a lot of time thinking about, and it's really about the knowledge, right? It's fine to have all the pieces of automation, but how do you, that's the easy part, how do you take that knowledge of how to invoke all the right things at the right time and hand them off to the people who need to take action and need to do it in a safe way, right? So it's compliant, and also there's the guardrails in place. So instead of having to say, hey, there's a problem, I now have to either read a wiki and figure out what's going on, or I've got to use some ad hoc tools. Is this the right script? Is that the right script? Or most likely what I'm going to do is I'm going to escalate, right? Now I'm going to interrupt somebody else with the problem. With runbook automation, it's all about taking that knowledge and pushing it closest to the problem so those people can at least try the first rounds of remediation. And if that doesn't work, they know who to escalate to. And again, my talk at 11:30, I'll kind of focus more in on this. It's a key part of the you build it, you run it methodology. And that gives us, shorter, incidents, but not having to go through these escalation chains. We're interrupting people who they aren't looking at their work. They're able to solve problems in minutes, right? Where I'm empowering the people with, here's the diagnostics, either solve the problem or to move on. It's got a couple more slides here, and it solves the problems of the compliance problems, right? How do we stop people from, they can't let them work in production. But if we give them an automated runbook, we can, right? Compliance is happy with it. And the folks at Capital One did this great presentation, the DevOps Enterprise Summit, talking about how, they think about runbooks and how it's really, being the key thing to drive their incident response times and their quality through the roof. And kind of last piece, learning from our incidents, John Allspaw, I highly recommend you go see his work, but he talks a lot about how don't focus on the outcomes, right? We just got to know the action items off this incident, right? Instead, the reality is it's the journey along the way. It's the learning where the organization gets better, right? It's all the little bringing people together to discuss in context what are all the things that came to cause this issue. That's where our mental models, our above the line mental models, start to align, so we can get better at these things, right? And again, incidents are unplanned investments, right? The ROI is up to you. So again, I think it's good to think about what are all get people on the same page as what are all the factors driving what we're doing today, and then divide up that the notion of an incident and kind of follow all these different areas and try to improve how we do things. Because again, it's better for the company, it's better for how we work, and it makes all of our lives a whole lot better. So that's my talk. Again, you can get the slides there, and if you want to hear more about some of these topics, I'll be talking at 11:30 in Rumford. So thank you very much.